Hey guys, here's the Spiral 7 review. We're going to start off with looking at sketching angles and general angle ideas. And for 409 degrees, I'm going to go around 360, and then another 90 to get to 450, and 40 more to get to 490 degrees. To find some coterminal angles, I might do 490 plus 360, and that would get me to 790 plus 60 is 850 degrees. I could also do 490 minus 360, and that gets me to 130 degrees. You need to sketch, you need to find two coterminal angles, and you are done. Moving on to question 2, we're looking for a reference angle for the given angle. We know that reference angle means the angle formed with the x-axis. So we're going to think about this in terms of pi's over 9. Okay, to go all the way to here would be negative 9 pi over 9, because that's the same as negative pi. And that means that there's only enough space for 1 pi over 9 in here. Because if I've got 9 pi over 9 and 1 more pi over 9, that gets me to 10. Reference angles are always positive, so I can treat this as a pi over 9. Converting from degrees to radians, we're going to multiply by pi divided by 180. Okay, I can reduce this by looking at dividing by 5. And 600 divided by 5 is going to be 120. 660 divided by 5 is going to be 132. Another 5 is 133. So 133 pi. 180 divided by 5 is going to be 20 plus 16. 36. Okay, and then if I look to see if there's anything these can be divisible by, 1 is okay, 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 no. I think that's about it before I start heading into things that definitely do not work. That may be reducible. I don't think it is. To convert from radians to degrees, I'm going to multiply by 180 over pi. My 18s can reduce, so I get 7 times 10 is 70, and then nothing left, so it's 70 degrees. Unit circle trig. Okay, starting out with tangent of 23 pi over 6. First thing is sketch this thing, and I know that 23 pi over 6 is pretty big. I might try to make this a little bit more digestible for me. I know that 23 pi over 6 minus 2 pi, or 12 pi over 6, is going to be 11 pi over 6. Okay, that's an angle that I'm comfortable with, because that, my friends, is a unit circle angle. We are down here. We know that this is a pi over 6 family, so this is going to be a 30, 60, 90. So if I set up my triangle, for tangent we need opposite over adjacent, so that's 1/2 divided by root 3 over 2, which is going to come out as 1 over the square root of 3. And in this fourth quadrant, we're looking at only cosine is positive, therefore we need the negative value. Negative 1 over the square root of 3 or negative square root of 3 over 3 are acceptable answers. Cotangent of negative pi. First thing I'm going to do is to figure out where negative pi is. Okay, going around negative direction, pi falls here. I tend to use coordinates for the 0s and 90 angles. And cotangent I know is going to be based on tangent of negative pi. Alright, and then take the reciprocal. Okay. Tangent of negative pi I know is going to be y divided by x here, or 0 divided by negative 1, or 0. Cotangent is going to be the reciprocal which is negative 1 over 0, which is undefined. Secant of negative 3 pi. So we know secant is going to be the reciprocal of cosine. And if I take a look at my circle, sorry, I just started going in a positive direction there. So we want negative pi, negative 2 pi, negative 3 pi, negative 1 comma 0. And as far as my cosine value, cosine here is going to be negative 1. Secant is going to be the reciprocal of negative 1. And this is really negative 1 over 1, so the reciprocal is actually the same exact thing, negative 1. Here we go. Cosine of negative pi over 2. Negative pi over 2 is here. Again, I tend to use the coordinates for my corners. Cosine here is going to be 0 because it's the x value. Cosecant of pi over 4. First thing I'm going to do is find sine of pi over 4 and then take the reciprocal. Okay, sine of pi over 4, this is going to be a 45, 45. So I got root 2 over 2's everywhere. Hypotenuse of 1. This is a nice first quadrant angle, so it's going to be a positive value. Okay, sine of pi over 4 is going to be the square root of 2 over 2. Reciprocal is going to be 2 over the square root of 2, which you can leave like that. That's an okay value for this. Or if you multiply the top and the bottom by the square root of 2, you get 2 square roots of 2 over 2, which reduces to the square root of 2. That's also an acceptable answer. Next up, we've got some beyond the unit circle trig stuff. I'm going to start off with this first guy. Cotangent is negative 4/7. Okay, first thing I do is I'm going to make a triangle. And for this triangle, I need to choose a side to be, or choose an angle to be my alpha. Okay, let's make it that guy. Cotangent is going to be adjacent over opposite. So looking at 4 and then a 7. I'm going to Pythagorize to get the hypotenuse. So 4 squared, 16. 7 squared is going to be 49. So this is going to be the square root of 65. Not going to come out clean. Okay. The other thing I have to figure out is which quadrant this is in. Cotangent is negative. I'm looking for places where tangent is negative. We know if all students take calculus, tangent is positive here and here. So we've eliminated those two quadrants because cotangent has a negative value here. Cosine is positive. Cosine is positive here and here. That means we're looking at fourth quadrant. In the fourth quadrant, cosine is the only function that's positive, so cosine is secant will be positive. Okay, so based on my triangle and based on knowing which angle we're looking at, we'll take a look at this. So cotangent, first one I might do is tangent because I know that's just the reciprocal. Tangent of alpha is negative 7 over 4. Nice. Cosine I know is supposed to be positive. Cosine of alpha is going to be adjacent divided by hypotenuse. 4 over the square root of 65. Or if you wanted to rationalize the denominator, 4 root 65 divided by 65. With cosine, I'm going to go with secant, so I can get the reciprocal one in there. And I'm going to end up with root 65 over 4. Taking a look at sine of alpha, that's going to be opposite divided by hypotenuse. 7 over the square root of 65, or if you wanted to rationalize that denominator, 7 square roots of 65 over 65. And to go with that, finally, cosecant of alpha is going to be root 65 over 7, flipping my sine value. Both sine and secant should be negative. I'm sorry, cosecant should be negative because we're down in the fourth quadrant. second problem in this section. So we're trying to find an exact value for 2 sine 30 degrees cosine 30 degrees minus sine of 2 pi over 3. Okay, well, let's find these trig values. Sine of 30 is going to be a half. Cosine of 30 is going to be the square root of 3 over 2. If you need to draw this out, that's fine. This is what your triangle would look like. And sine of 2 pi over 3, that's going to be a 60-degree reference angle, is going to end up being the positive root 3 over 2. Okay. 2 times a half is 1. Root 3 over 2 times 1 is root 3 over 2. Root 3 over 2 minus root 3 over 2 is 0. That's kind of cool. You end up getting 0 for an answer. Next up, we got some graphing stuff. All right. Looking at negative 2 cosine theta minus 3. I'm going to graph this using the same method I always do. And I'm going to start off by finding my midline. Okay. So midline is going to be minus 3. So I'm going to draw my midline. Okay, there we go. Again, I also like, I've talked to you guys about this, I like to use my midline and then take a look at my amplitude just to kind of give me some boundaries for which I can graph this thing. You don't need to do that at first, but I find that to be helpful for me. Okay, then I'm going to have to do my endpoints. So I need a beginning point and an end point. Okay, I'm going to set the inside, equal to 0. And then the inside equal to 2 pi. That's interesting. I didn't have anything going on the inside, so my endpoints don't change. I've got a negative cosine function. We know that's going to look like this. So I'm going to start down at the bottom of my amplitude at 0. I'm going to finish up at the bottom of my amplitude at 2 pi. And then I'm going to go exactly between these two for the middle. So now we've done the midline, the endpoints. I need the middle. And the middle is going to be pi, and I'm going to go to the top of my amplitude. Okay. Finally, after I've done midline, endpoints, middle, I'm going to do the last two. Okay. And that's going to be exactly between each of these, so pi over 2, and sit on the midline. Same for the last one. We're looking at 3 pi over 2, because that's in between. For cosine, those last 2 points end up on the midline. So you can get one period that looks like this. Huzzah! For our last one, we're looking for an equation using sine to represent this curve. Okay. Let's see if we can find some stuff here. Okay, first thing I might do is try to find the midline. That looks pretty good. And that's going to have a height of 2. I'm going to write midline equals 2. Nice. Second thing I might do is to find the amplitude going from the midline to the peak. Amplitude equals 3. Okay. We know we have to use sine because we're asked to use sine. And this is going to be a positive sine graph because the sine mother function looks like this. The negative version would have been going down first and then up. Okay. So we've got sine, we've got amplitude, we've got midline. The period here, I know I advise you guys to try to do top to top. We can't. So I'm going to do going up. There's 1 half period. There's 2 half periods. That's where my next period begins. Okay, because that's 1 full cycle of this graph. Going from 0 to 2 pi, we've got 2 pi as a period. We know that period is equal to 2 pi divided by b. In other words, 2 pi times b is equal to 2 pi. Divide both sides by 2 pi, and I get b is equal to 1. All right. And now we've got to think about our phase shift. In looking at this, we're starting at 0. That's the normal starting place for sine. My phase shift is going to be 0. Okay. Setting up my equation, we know we're using y is equal to a sine the quantity b times the quantity x minus c plus d. All right, now let's put this thing together. So we're using positive sine. So positive amplitude 3, sine b of 1, x minus phase shift of 0, plus the midline of 2. You could also have written this as 3 sine x minus 2.